Well, let's continue our discussion from last time. This time we're going to use long division. Only this time, if you recall, our answer from the last session would have been this. Hopefully you got that same answer that I did. If you did, congratulations. If not, that's all right. We can go back and take a look at what you're doing if you want to come by ADI or talk about it in class. Makes a good question. All right, so let's talk about this, long division. Well, you remember how long division works. In this setup, we've got a dividend, we've got a divisor, and we've got a quotient. And after we do our work by multiplying the pieces of the quotient with the divisor, we get subtraction, we get our remainder at the end, right? And of course, one way of writing this is that we might say that, well, if we took the dividend and divided it, dividend, let's see if I can write dividend here in any sort of serious way. Dividend divided by divisor, there we go, there's the divisor, is all equal to the quotient, whatever we get. And if you remember, that would be added to the remainder over the divisor. I'm going to abbreviate there. Okay, so kind of remember how this works. Let's just remind ourselves, if we're doing long division, let's say numerically, we would have divided 47 by 11 by taking 11 as our divisor, 47 as our dividend. And let's ask ourselves, well, how many times will 11 go into 47? Well, the answer to that, of course, is 4, because 4 times 11 gives us 44. Then we subtract. We end up with a remainder of 3. So we could stop right here and say, well, then in this case, 47 divided by 11 would equal 4, which is our quotient, and 3 11ths, right? So that is the quotient plus the remainder over the divisor. Now, again, we're not doing the decimal thing right here, right? Remember, if we had the decimal, we'd put a decimal, we'd follow a 0, and we'd bring down the 0, and then carry on from there. But we're not going to do that. We just want whole number divisors along with quotients. So let's ignore this piece right here, because we really don't need it. All we're going to do is we're just going to use the remainder portion this time in our arithmetic. All right, so how does this work when it comes to polynomials? Well, actually, not that much differently, surprisingly. We're going to set up everything in sort of the same way that we did before. We have our divisor, in this case, 3x minus 4 outside of our division tableau here. And underneath, we're going to put 6x cubed plus x squared minus 18x plus 10. And what we're going to do this time is that when we start coming up with terms, what we're going to do is we're going to look to see, well, how many times would I have to multiply 3x to get 6x cubed? So the only thing we're going to concentrate on is one term at a time, and we just want to make sure that whatever we multiply up here in our quotient multiplies by that leading term to give us the leading coefficient right here. So the leading term of the divisor to the leading term of our polynomial written in descending order. Well, 3x goes into 6x squared. 3 goes into 6 twice, right? So we'd have to multiply 2 times 3 to get 6. But what would we have to multiply by x to get x cubed? The answer to that is x squared. Right? So this is our x squared column over here, and we're going to take 2x squared times 3x. That's going to give us 6x cubed, and that's exactly what we wanted. But then we also have to take 2x squared and multiply it by the next term in our binomial here, 3x minus 4. So 2x squared times minus 4 is going to give us minus 8x squared. So how do we handle this? Well, we subtract everything that we just got from the terms above it. And of course, the idea was that this is exactly what should happen. We should get 6x cubed minus 6x cubed to give us 0. And this time we're going to take 8x, we're going to take x squared, and we're going to subtract negative 8x squared. So this is actually going to become 9x squared minus 18x. We bring down the 18x here, just like that, along with its sign. And so our next aim is to find out, well, what do we have to multiply by 3x to get 9x squared this time? Well, the answer, of course, is going to be plus 3x. And that's because 3x times 3x is 9x squared. But then we take our 3x and we multiply it by negative 4. 3x times negative 4 is minus 12x. And so now we're going to subtract again. So we subtract away everything that we just multiplied in, just like we did before. 9x squared minus 9x squared gives us 0. Negative 18x minus negative 12x. That's negative 18x plus 12x. So we actually end up with negative 6x here. We bring down the last term, plus 10. Now, we notice that 3x minus 4 and 6x and 10 are the same degree. So we're going to have one more term to our quotient up here. That is, whatever we multiply by 3x should end up with negative 6x. And the answer to that is, well, negative 2. Because if I take negative 2 times 3x, I get negative 6x. And if I take negative 2 times negative 4, I get plus 8. And now, just like we did before, we're going to subtract. Negative 6x minus negative 6x, that just gives us 0. But 10 minus 8, that's going to give us 2. Well, 3x minus 4 won't divide into 2, right? There's no x in this term left. So we're done right here, and this happens to be our remainder. Okay. So how do we put that together? Well, since our division is the dividend divided by the divisor, our result should be the quotient plus the remainder of the divisor. So our answer right here, our result of this division, will look kind of like this. 2x squared plus 3x minus 2 added to our remainder of 2 over our divisor of 3x minus 4. So if we're presenting this result, this would be the way that we would want to present it. More in the next video.